Hello. Hello, everyone. Good evening. My name is Girish Dhanakshirur. I think hope we are live. Yes. Good evening, everyone. My name is Girish Dhanakshirur. I'm the director and CTO in IBM Cloud, Cloud division. I'm very much based out of Bangalore. So I'm part of India Software Labs. Uh, Let me first start with wishing all of you staying home. Hope you and your families, you're all safe. Given the COVID situation, what we have around us. And thank you so much for NPTEL for inviting me. To deliver this lecture. Um, so today we have a very interesting topic. Let me just transition over to my slides. Today we have a very interesting topic. We can talk about. So let me just switch over to my presentation here. So we'll talk about the role of cloud native architecture in cloud applications. Um, I'm guessing that many of the institutes today offer various courses in cloud-related technologies, be it cloud computing, be it storage architecture, data structures in cloud computing. There are many such topics that today universities and universities offer today as the as part of the curriculum. Um, so we will talk. I want to give the industry perspective on how these things are evolving. Um, how things are evolving and um, how it works in the real industry, and then sort of connect that what happens in the industry to some of the curriculums that we frame in the universities. So that was the whole intent, and I've had close to 25 years of experience in IT industry, and about close to 6 7 years building cloud technologies or cloud-based infrastructure, cloud-based applications. I've got some good amount of experience working in IBM, especially on IBM Cloud. So let me start off with this very interesting phenomenon that we see, and this is also sort of like disrupting the industries. Um, so by the way, if you have any questions, periodically I will flip back and look at the form. So feel free to ask your questions there. I will try to answer as many questions as I can. If I don't have enough time, then I will ensure I'll take the questions offline and then still reply to each one of the questions. So there is this thing called as Uber syndrome. What it means is, so this is the CIO of Schneider talked about this a couple of years ago. It's where a competitor with a completely different business model enters your industry and flattens you. So I'm pretty sure. I think which what I'm talking about here, because we have seen many such examples right here in India. Um, let's say if I can use some of the examples. So let's say Ola. Ola has essentially changed the way the whole rental or car rental or cab service business operates completely. Here in India, and it's not a car company. It's not a cab company. It's a technology company. It's a technology company offering um, various sets of services uh, using an app that every driver and as well as commuters like us, we carry, and they just have massive infrastructure that's running perhaps on a cloud, and it's connecting us versus commuters with the drivers, and then what gets done. So this is a classic example of what's called as Uber syndrome, which is happening across many industries. It's not just just the commute or car rental business. It's happening in the hospitality industry. So there's a company called Airbnb, which is very popular in North America and Europe and some of the other countries. So Airbnb is all about again using an app. You just book a room before you enter in, and then on the other side, it doesn't have to be a hotel. It could be just an apartment. You're living in an apartment. You have maybe one bedroom available. If you want to just rent it out to someone, you just post it on Airbnb, and someone can look at it and then join. So these are some of the new breed startup companies that are primarily technology companies. And these technology companies can scale at a global level. Um, so today's discussion is all about what kind of technologies they use and how do they become successful by delivering that kind of experience to their end users. So we'll touch upon some of the technology areas that we really want our students coming out of universities really equipped with those skills, because at the end of the day they will end up working for these type of companies. It could be Ola, or it could be any a cloud provider. It could be an IBM Cloud. We have our own cloud, so we use all these technologies day in and day out. So the industry is looking for these type of skills coming into the workforce, and there's a lot of research areas here because we have industry has not solved all the problems. When we get into this, and then there's a new set of problems. So there's a lot of research area. So someone pursuing PhDs, there are very many areas that they can pursue here. So I've broken my agenda today into these four areas. So we'll talk a little bit about cloud native apps. We'll talk a little bit about monolithic versus microservices, something that you'll probably hear very often. And then we'll talk about some of these organizations. I used Uber as an example. So we'll talk about how these high performing organizations are structured, which enables them to deliver technologies at that pace. And then lastly, we'll talk about micro-frontends, some evolving technologies in the space. I will probably defer, some of the discussions, some of the topics which are fairly advanced, things around serverless technologies and whatnot, perhaps for next lecture. So let's start with what are cloud native apps. So cloud native is essentially, it's an architectural principle, and it relies, or the basics of that essentially is, how do you make a service available which is always on and which it can scale. So the whole notion around how do you build a service, and then how do you offer this so that it's available all the time. So let me quote an example. So IBM has a service called or an app called Weather app. You can go in the Play Store and then use the app. So it's available across the globe. Every country, every state, every district, can open that app and then look at weather data for that region, for that state, and the weather pattern, the next 5 days of weather forecasting and stuff like that. So that's a service, and that's a service that's offered on cloud. So what we're talking about is, how do you build such service that's always on, and it can scale. It can scale from, let's say, 10 million users to 100 million users, let's say in a couple of hours. And we have seen these examples. We have seen the scale coming in. So we have seen many examples. So for example, let's say this typhoon coming, and within the typhoon, at that time, uh, or there's a depression. The depression is throwing lots and lots of clouds and lots of shower, lots of rain coming in. So at that time, suddenly you've got let's say a crore population going and downloading this app and then checking the weather forecast. So that's the amount of load that's supposed to go up. The app is not supposed to crash. The app is supposed to deliver service. for all those users. Once everything is over, once you're back to normal, and then it's supposed to go down. So this is all about service availability and scalability. Uh, Redundancy has to be built into it, which means, even if something crashes in the service that's running on cloud, the app should still be running. You have to have the redundancy over there. You have to have scaling. The next thing we will talk a little bit about this is something called as DevOps. You might have heard this term. You'll probably hear more. So what DevOps means, it's operations team which runs the operations of a cloud, of an infrastructure, and then developers building applications. How do you bring both of them together and put them together to deliver and maintain a piece of code or a functionality on the cloud? So this concept is called as DevOps. And all this is about automated way of deploying and then updating the service. So it's all about that. The last one is how do you know how things are working in cloud, or about your application, or about your service that's running? So which means you have to have logging, monitoring, alerting, and then backup and restore. All of that has to be part of operations. So while building an app or a service, how do you keep these three dimensions in mind about service availability and scalability? How do you deploy, automated way of deploying? And how do you monitor the app and service so that you can quickly react? How do you bring this, and then how do you bring this into an architectural principle while building your application and deploying? So let's take a look at a very simple example here in a very simplified way. I'm just showing this in a very simplified way, how the design looks like. So let's assume you have built a calculator application, that you want to make it available across all universities. It could be a very scientific calculator, does something which is very unique, which is not available in any calculator. So your calculator code, let's say if you have written that in Java, you want to make it available on some cloud, so that from any university, someone can open a mobile app and then connect to the calculator and then use it. Or just someone can go to the desktop, go visit the URL, and then from the URL you can access the calculator and then use it. Let's say the calculator also has a very small database where you store some data, so that you can look up in the calculator computation. So in this picture, what you see is when someone looks up your calculator endpoint URL, it hits the DNS of your cloud provider. Now what you see is two lines here, which means it gives you it avoids a single point of failure. So which means your calculator code will be running in one of the app service box. So your Java code you package, and then you deploy in one of the app service box. What you see there in the yellow group is what we call a scaling group. As and when the number of users accessing your calculator increases, the number of instances or number of replicas keep on increasing automatically. So that's what we call as auto scale. So let's say if there are 10,000 users, and let's say it goes to 10 lakh users, number of instances go up, and then automatically the load is handled. And there is a load balancer that sits right above that. So you've got the load balancer, you've got your app running in a scaling group, and then you have the database where you're storing your information. Now this is wired to the DNS, at the top, where your users access the endpoint. The user, whenever they access, they come to DNS, and then they go to load balancer. Now your app is, let's say, deployed in two regions. So you have deployed this, let's say the cloud, you have cloud available, like for example, in IBM Cloud, we have one data center, we call this as data center, available one in Chennai. The other one is available in Singapore. So you can think about the one on the left is Chennai, the one on the right is Singapore, and then you have the request coming in, from a DNS perspective, it's coming into one of these data centers. So request comes in, goes to Chennai. From Chennai entry point, load balancer, it goes to your app service that's running inside the scaling group. It also picks up the database, and then the database is replicating between Singapore and Chennai. If the second user comes in, the second user goes to Singapore. Now, let's say for whatever reason your app crashes in Chennai. No one will notice that because your request will go to Singapore data center and the app service that's running in Singapore. So the idea behind most of these successful companies running highly scalable applications, this will be fundamental to their design. So, and this is also how they offer 24 by 7 availability, what we call it as 99.99 availability. So what you notice here is there is no one single point of failure. So if one app service instance crashes, the second one takes over. If one data center goes down, the second data center takes over. And then once it comes back, it load gets evenly distributed. So this is a very classic way of building these applications. So your unit, which is your calculator code that you've written in Java, in cloud world, we call these as a single unit of execution that will be packaged as what we call as containers. So containers are becoming very common in today's cloud technologies. So if you can see the definition, a container image is a lightweight standalone executable package that includes everything needed to run it. So it includes your Java code. It also includes your runtime, which could be, let's say, a Liberty runtime, or if you're using PHP, there's a PHP runtime. And it also has the kernel. It also has the operating system. All of it packaged into one thing called as container. And this unit becomes your app service on the previous slide, or app service, what I mentioned here. So your calculator code goes in as app service, which is built as a container. And the beauty of this container is most of the cloud providers or most of the cloud vendors offer a very seamless way of building these containers. So students will have to be familiar with the concept of containers, how to build them, how to optimize them. And the beauty of these containers is these are language agnostic. So which means I can build service 1 using Java. I can build service 2 using PHP. I can build service 3 using Python. And all of them, I can run it in just one cluster, or I could even run it within one service. So here is an example. So this, let's see if I stretch your calculator example. So your calculator could have scientific, which could be route A, standard, which could be route B, and you can think about some of the other ways of exposing your calculator. Your service, you can define a service A to be service that's written to do scientific calculator written in Python. You could have service B, which is doing standard, which is written in Java, and so on and so forth. So this is how you can structure your web server, and then this is how you can structure your application architecture. So now let's switch the gear a little bit, and let's talk about monolith versus microservice, because I think most of the students in the universities learn about Java, learn about data structures, learn a little bit about architecture, learn about waterfall model, agile models and stuff like that. So when we look at monolith applications, by the way, this is how we used to build applications for the last 15, 20 years. It's all about a single executable unit. The benefits are, it's very simple to deploy, test, develop, test, and deploy. At most one technology. So for example, if everything what we build for the backend is in Java, everyone writes Java code. So there's millions and millions of lines of Java code that gets written to make that as a single executable unit. And then you can run multiple copies of that big monolith if you want to scale. Now there are a number of drawbacks with this architecture style. So number one, it's huge. For example, when developers want to learn how it works, it's very intimidating for developers because it's just one monolith. Lead times for releasing, it's about 4 to 6 months if they want to test and release, because everything has to be tested. If something gets broken, they have to go back and test it. So the lead time, there's a long lead time. And then it increases the risk of failure. For example, 4 months you take it and then you deploy it, suddenly something crashes, doesn't work. You've got to go back and then redo it for, let's say, 2 months to fix and redeploy it again. So So there are a number of drawbacks with monolith-based application architecture. So there's something called as microservice architecture. So again, this is an architectural style where applications, what I spoke about on the previous slide, gets broken down into smaller autonomous services that work together, and these can be independently developed, run, and operated by different teams, and these can be written in different languages. So what you see here, so there's an account service, there's inventory service, there's shipping service. Each one is a microservice written in a particular language, exposed as APIs for someone to consume. And this can be developed by team A, and inventory service can be developed by team B. And team A, as and when there is new feature or whenever there's a bug fix, they can independently go and fix it for account service without worrying about whether inventory service goes down or whether shipping service goes down. So that's the beauty of the microservice-based architecture. Now, of course, the trade-off is the microservice-based deployments can get overly complicated. There's complexity involved, and that's something that students will have to be aware of. And there are many ways to tackle that, the complexity problem. But then again, that's a trade-off for monolith-based architectures. So how do you build and deploy these artifacts or these monolith versus microservice? So what happens in monolithic architecture? So this is like your Rubik's cube. There are many small pieces tied together in one big thing, and it goes through an automated acceptance test, automated testing, manual explorative testing, and then it goes to a release. It's essentially like a train going from step one, as opposed to a microservice-based architecture, which is what you see at the bottom. So you have different pieces, different components that can run on their own. They can go through the same 4 steps, but then each one can have its own, and then they all go to the system integration testing where it gets packaged and where it gets released. So what it allows you to do is it enables separation and independent evolution of code base, technology stacks. It can scale. For example, you can take just the red component and then you can have 100 instances of those, while your green, yellow, and blue can be only 1 or 2 instances. So you can independently scale each one of them, and then you can deliver features at a different pace. So here's an example of a microservice-based next-gen architecture. As you can see, you have all the backend systems, and then there is the microservice layer where you have a whole bunch of microservices, and then there's a whole bunch of BFF, what we call as backend for front end, which sits in the front, and then mobile applications, web applications, IoT applications will talk from the top, and then that's how they access. So all the layers from what you see, the login and those components, they'll be running, let's say, on cloud. Everything else goes behind that is a cloud-based architecture. So we also talk about hybrid cloud architecture. So this is an evolving space. At some point, I would assume there will be courses that will focus only on how to build hybrid cloud architecture or hybrid cloud applications or enabled applications. So this is perhaps I'll park it for maybe a future lecture. But what you need to just realize, or what we do in the industry, is what you see on the right side is your traditional core enterprise, or what runs within a bank or within an insurance company or within a travel and transport within a travel industry. It runs over there. It has processes, it has apps, it has databases, interaction layers, or whatnot. And then you have applications built using cloud native technologies. That's on the left-hand side that you build. And then, so there is a glue that connects these two in a secure way, these two pieces. And then you get the benefit. You get the benefit of high-speed cloud native on the cloud, as well as the agility and security, as well as reuse, that's coming from the core enterprise. So what we call this is multi-speed IT. So companies can deploy value to their customers very fast. Okay, so before I switch over to organization structure and culture, let me just flip over to see if there are any questions in the form. So feel free to ask questions in the form. Um, so there are questions about cost element. So typically in cloud, when you build cloud native applications in cloud, what we call, so it's usually subscription based. So the cost model would be around, basically you use a particular runtime, you use a particular database, you use a particular service, you pay only for that, you don't pay for the whole thing. So generally it works out much better from cost perspective. Um, I think there are some examples around questions around security aspects. So security is very critical when it comes to building these applications and deploying. So there are bunch of books that are written on how to build cloud native applications keeping security in mind. So there are things around, where to store data, how to handle data, how to handle SSL, between the client and your backend. How do you factor in customer data, how to store, where to store. So there's a lot of literature available around security, but then generally security is taken very seriously, especially when someone is building applications. Um, I think there's also a question around, how do we ensure, Docker, or the Docker container dies or Docker loses or whatnot, right? Yes, that's a very good question. Um, in cloud, we'll talk a little bit about that as we get into some more material. It's all about fail fast, and you don't worry about a container dying, because there is another layer in cloud, what we call as Kubernetes, and Kubernetes generally takes care of ensuring there is one service running all the time. So if a container dies, it's its job to bring up the next container and make the service available, right? So ensure. So that's built into the cloud architecture. Unlike, let's say, what we used to do in the past in a traditional way, where if something crashes, you have to go and reboot it, or if something crashes, you have to go and unload it and then reload it again back. In cloud, some of these things are taken care of. So I'll come back to the remaining questions in another 10 minutes. So let's continue. So in organization structure, when you look at some of these very fast moving startups, that go from, let's say, 5-member team becoming a runaway success, and suddenly, they are catering to all the users in India, hundreds of crores of users. So how do they operate? How do they operate, and what philosophy they follow? So they're generally what we call as high performing organizations. In general, they outperform from a throughput perspective many times than their nearest competitors. At the same time, they also offer a fantastic NPS, Net Promoter Score, so which means delighting their end users. They do much better. So, for example, if there is a bug on a particular website, or if there is a bug in a mobile app, or if there's a bug in certain other kiosk app, if they see it, they can quickly fix it within an hour and then deploy it, so that when somebody refreshes next time, they don't see it. So it's the pace of delivering that feature is something that you get using this cloud native architecture on cloud. So that's improvement of NPS score, and there are other benefits. What this also allows these high performing organizations is about experimenting with releasing something which is just give a try for 10% of the users and see if it works. If it doesn't work, then pull it back. If it works, then expand it to all the users, 100% of the users. So this is what we call as A/B testing, or canary deployment, which is essentially experimenting with a small set of users. If it breaks, if it doesn't work, just pull back. If it works, then expand. Right. So that's the experimentation. So there's this model called as Spotify. It's a company called Spotify. They were the pioneers of this model. So they came up with tribe, guild, and squad model, and this is very popular. If you look at high performing organizations, they are structured. So they're structured in squads. I'm not going to go through each one of these, but then again, it's a self-contained unit with developers, with offering people, with managers, with designers, all put into one tiny unit of 8 to 10 member team, and they're responsible from building to deploying as well as maintaining that particular service or that particular application. So this allows them to move very fast, and they can incorporate what I spoke about on the previous thing called as A/B testing or canary testing. They can participate in that very quickly, and they can roll out features very quickly. Extension of that is what we call as, if you take, let's say, tens of squads, they make it a tribe. So a tribe is something that have one common purpose. So this could be, so let's say, a complete app is owned by this particular tribe. A different app is owned by a different tribe. Tribe has squads, and what you see, the red dotted line is, so let's say if there are DBAs sprinkled in every tribe, um, if you take all the DBAs together, they become a guild. So there's a concept of guild, which means they can come together, they can talk about the challenges, they can talk about the topics around common interest. So there could be a guild of designers. So designers can come and talk about design things. There could be a guild of managers. Managers can come and talk about the management issues. So this is how they usually organize. So there is the thing around when you deploy at such a large scale. I think there was a question someone was asking, how do you take care of security and compliance, or how do you ensure security is in place? So this becomes part of the this become part of the it becomes part of the culture to ensure there's control and compliance when you deploy your service. So you can do it in certain ways, and this is what many cloud providers follow. So there's the hooks, there's the implementation of hooks during the build and deploy time. So that's one part. I'll show a picture in a second. And then the second one is when you talk about the containers themselves, are always standard. So that's the second one. And then in every service in cloud, you embed an agent, which is a compliance agent, which always checks for compliance, which means there's no hacker coming in and making changes to an image or making change to a container and then compromising the security. So if you look at this picture, so you will have developers building the code on the left hand side. They will push it to a repository, like for example Git. Once the code is pushed to a repository, you go through a build and deploy step. So you can put a control point in build and deploy. So this is your first step for security. You can do code scan, you can ensure some malicious library is not injected, you can do those type of scans. So that's your first control point. Once it goes in the deployment phase, you have two control points. So there's the compliance agent that's always running and making sure that no malicious code is injected. So that's checking all the time. And then the base image that your service is packaged is also certified. And whenever you do an upgrade, you also always upgrade a certified image. You don't take an image which is not certified. So these two or three, and perhaps there could be some more, this allows you to have checks and balance or control and compliance in your deployment. So this is a very interesting topic. This in itself, I have seen MIT, I have seen Stanford. Many of them offer a complete course just on SREs, site reliability engineering. Of course, Google was the pioneer, in coming up with a very well thought out, structured way of engineering. So this all came from operations team. How do you take the operations team who were doing mostly shell script and managing infrastructure, bringing them all the way back as developers, and then making them view infrastructure in a completely different way. So, for example, if you look at what's their number one number one metric or KPI. It's what we call as mean time to restore, MTTR. That's a key measure for them. So there are things around, they continuously build monitoring systems. They continuously monitor the infrastructure. They continuously monitor the application, that's been deployed. They believe in removing any manual step. It's always automation, automation, automation. So there's a thing called as toil, TOIL, toil. So toil is the amount of time wasted by doing something manually, and if it goes beyond certain percentage, then they get dinged. So which means they have to continuously work on automating the stuff so that they can reduce the toil time. So automation is very key for them. So things like what they look at is the fail-safe concept. So there's a concept of error budget. So the error budget is about how long in a month you can allow a service to go down. The service going down, which means, so let's say if I claim that in a month my service was not available for 23 minutes. So if I say 23 minutes was my downtime, it means my availability was 99.95. So you can claim that I'm running at 99.95. So SRE teams will give something called as error budget to the development teams, and the development teams will have to stay within their error budget. So if their service goes down for 25 minutes in a month, SRE team can tell the developers or the engineering team saying, you guys are done, you cannot deploy any new features for the rest of the month because you have already crossed your error budget. So which is the error budget that was given was you can be only up to 0.05% from their error budget. So there's thing around error budget, so which means they maintain the resiliency and whatnot. So SRE is becoming very popular. It's key skill that's required across many companies, startup companies, cloud companies, many of the other companies. They're looking for dedicated SRE engineers, and it's a big field. I think from an academic perspective, I think we need to focus more on building these skills and building more SRE engineers. So let me touch a little bit upon microservice versus micro frontends. So the microservice we talked about, if I go back to your calculator application, so your calculator application that was built as a microservice was running in cloud, you packaged it, ran it as a container, Docker container, you're running it. So now the concept of extending the microservice to a micro frontend, so which means if you have built, let's say, a web app, within the web app, if you have a gadget that represents your calculator, that's a micro frontend. So there's this concept of micro frontend and microservice coming together as a single unit, and how do you package and how do you build and how do you deploy as a single unit? That's becoming very popular. So let's take an example. So in this case, we have a resort booking application. The resort booking application could have multiple microservices, right? So there's a login microservice, resort booking microservice, there's a chat microservice. So these are running in backend. So if I take this, and let's say if I take to the mobile front end, probably we don't look the backend. We just say these are the APIs available. We just go code the whole web application using all of these APIs and then build one mashed up application. So if you look at the microservice architecture, we built the login microservice, we built the resource booking microservice, we built the chat service microservice. Similarly, we can also build a login micro frontend, resort booking micro frontend, and then chat as a micro frontend. So the micro frontend microservice become one single unit. This is very important concept that you have to keep in mind, because we abstract away the construct of languages in a container. We spoke at the beginning. I can build the login service using Java. I can build the chat service using Python. I can build the resort booking in a different technology, let's say PHP. So we have different technologies for these microservice. Similarly, I can also adopt login could be built using a particular framework. Result booking could be built using different framework, and we attach these into single set of units. It becomes the single deployment artifact. So the team or a squad that's running or that's building the booking service, they will have the front end team, they'll have the back end team, and they'll work as one team to build the single unit. They build, they deploy, they maintain, they manage that one particular service or that one particular feature. So this is becoming very popular in modern architecture. Okay, so I think that's pretty much all I had from a content perspective. I know we rushed quite a bit in in uh, in some of these areas. So let me take a look at some of the questions. Um, okay, so there's a question about role of cloud in India. Um, Very good question. Um, it's just in my view, I think we have scratched the surface of using cloud, in terms of adoption for many of the things that we do here. So if I look at any popular app that you have today on your Android phone or an iOS phone today, the backend runs on a cloud. Either the cloud is deployed in India or the cloud perhaps deployed somewhere else. Each one of those apps, they connect to a backend that runs on cloud. So which means cloud is already here. Cloud is already becoming a major force in driving a lot of innovation. Things around, and let me talk a little bit about why cloud could play a significant role in India. In India, because of the amount of adoption that we have, I think it was our Prime Minister. He talked about close to um, 500 million users, which is about 50 crore people having a mobile phone today, mobile app, pretty much in a city or a village or a district, everyone having an app, which means they have access to internet. So which means anyone, any startup company can build a service and have the ability to reach 50 crore users in a single day. So when we say a successful startup building an app reaching 50 crore people, which means it has to have enormous compute capacity to handle the load, either running the app, the code that you wrote, or the database, or the messaging queue, whatever it is, it has to be. It can be delivered only using cloud as a technology to back it up. So there are many providers in India today offering highly available clouds, and like I said, I think it's we just scratched the surface of cloud. Yeah, I think there's one more question, which is, should we think DevOps with availability? What kind of skills required, from individuals, and then, what are some of developer-friendly, frameworks? So let me comment on a couple of things there. So one is yes, DevOps and availability go hand in hand, um, because what DevOps does is it brings in the concept of automation into your development as well as operations. So you don't have manual intervention of someone bringing down the service. So you don't have a developer that's writing a bad code and then bringing down your service or a website or an app. You don't have an operations person, who is going and deleting something by mistake and then bringing down the application. So what DevOps gives you is the ability to remove manual intervention from this whole aspect so that the whole thing gets automated. Automation also brings the repeatability with confidence, which is if you know that a DevOps pipeline ran and then it deployed the code to a particular service, you are sure that you can do it 100 times and 100 times it will be successful. So the repeatability and confidence, it brings in, it brings into the engineering field, so you can really deploy it with confidence. And hence, I think, as you rightly pointed out, DevOps and availability, go hand in hand. Frameworks. So let's talk about, a few frameworks that, I really want universities to also adopt, and start teaching people. For full stack developers, it's all about, popular technologies, what we have today. There are many technologies, but at least the popular ones continue to be React.js, very popular. For mobile developers, React Native, Node.js, number one. Things around SQL, non-SQL. If you're going with SQL, continue to have MySQL in your curriculum. Non-SQL, NoSQL, Mongo database. Again, there are many variations, and I'm not going to go through the other ones, but the full stack developers have to have these kind of skills. Have Python. We do a whole bunch of stuff for running cloud. Python is given. You have to have Python skills, automation scripts, things around DevOps framework. Look at the DevOps framework. Um, Things around. So we talked about the front end. We talked about the back end. Pipelines. Jenkins is another given. You have to have good skills. Um, Good skills. Teaching Jenkins as one of the DevOps tools. So those are some of the things that you should consider. Skills set of required for individuals. I think we talked about some of that. Um, I think there was a question around, is there consequences of overcapacity in cloud? Okay, that's a very good question. So first of all, uh, the beauty of cloud is, so there is a clean separation of where your app runs and what infrastructure you need at the bottom. So if you look at, some of the architectures of how cloud infrastructure is built, it's very loosely coupled and layered architecture. So which means, if you can, if you let's say if IPL is running, and IPL requires, let's say, 1,000% more capacity, not just 100. I'm talking about, hundreds of times of more capacity. Cloud, it can easily be more compute can easily be added, and it can be put on standby. Application will not even notice that, more capacity was added under the covers. So it's not like, you have to go, bring the server, prep it, install the software, install your application on that software, and then bring it into the cluster. No, it doesn't work that way. Cloud can elastically add more compute capacity, elastically remove the compute capacity if something is not required. So that's a beauty of elasticity and scale, that you get with cloud. And most of the cloud providers today, that we have here in India or anywhere else, are very well equipped, in order to scale, add more capacity. Uh, so that's a good question. Importance of AI in cloud computing. Excuse me. Uh, AI, at some point, at some point, AI will be baked everywhere. You will not even notice AI will be there. But some of the important ones, I think we talked about DevOps. In DevOps, we talked about repeatability. We talked about automation. And today, we have DevOps engineers, who are building the automation scripts and who are building the automation, and then, using those automation to deploy cloud native applications on cloud. Eventually, we will have AI bots taking good amount of that work away from, someone building and someone running or someone managing that infrastructure. So, AI, machine learning will learn from data, insights, existing patterns, and they can learn from those, and then they can automatically build, certain skill sets, or they can build certain scripts by themselves and start managing the infrastructure. So there's a lot of scope for AI from an operations perspective. So we call that as AI ops. So that's a growing field as well. But there are a lot of cloud vendors who offer AI services. So, for example, if you want to do NLP, natural language processing, using terabytes of data and then looking for patterns and stuff like that, you can do that. If you want to do image recognition, there are services available to do image recognition. You can bring in a lot of corpus of image data, and then you can do object detection from the amount of image data that you have. You can use that as a service. So there are machine learning for chatbots. So you can train a chatbot. You can train a bot which can understand someone asking certain questions, and it can intelligently answer. So that's a service that's available on many cloud vendors. As developers, you can use those. So like I said, there's the part which is end users using the cloud service for some of the AI activities, and then AI used to build applications and run and manage cloud itself. That's a phenomenal field. So AI, like I said, will be there everywhere, going forward, and um, uh, machine learning and AI, both of them, it probably becomes a core of the fabric. There's one more question around edge or fog node architecture. So let's talk a little bit about edge here. So uh, many vendors today are looking at the next frontier of technology to be edge computing. So let's talk a little bit about that. So today we see that um, cloud, what we offer today, is still very distributed, and it's a data centric way of offering a service. So today, if you build, we go back to the calculator app. The calculator app you build and you deploy, and it will run in a data center. For example, it could run in Chennai data center. So if you are accessing that application, let's say from Jaipur, if you're accessing that from Jaipur, request goes all the way down to Chennai, and then you get the response back. What we are looking at is how do we take this app that you are running, on Chennai data center, how do we push it down all the way down to a pod that's very close to Jaipur, which is an edge server that's running very close to Jaipur, and we know that this app has not changed and will not change for next couple of weeks, so it can be cached and it can be serviced. Request can be serviced, from an edge service that's running very close to Jaipur. What that gives you is a very, very low latency. So with the coming of 5G, uh, it will be here at any time. So 5G will allow cloud computing in architecture to allow this type of edge computing that can bring these applications very close to where your users are. So, for example, so most of the Mumbai users today could be stock trading applications or banking applications, insurance applications. We want something that runs very close to Mumbai, so that the latency is very minimal, and then we don't want the requests coming in loads and loads of data flowing all the way back from Mumbai to Chennai and back to Mumbai, right? So we are building infrastructure, we are building architectures that will push this one out to very close to where the users are, and then we can service the requests, at that point. So this is a very fast evolving field for edge computing. So keep an eye on edge, 5G, and applications built using, or exploiting these technologies. So that's the next frontier of innovation, and that's the next frontier of cloud computing. I think there's a question on asking to share the PowerPoint presentations. Excuse me. I will add at the bottom, and then I'll find a way to share the presentations. I think we talked a little bit about hybrid cloud. That was a good question. We talked about security. I think that's a good question. We talked about edge. I think that was a good question. Just going up the list here. Uh, we also talked about microservice architecture in relation to what we do for cloud native applications. I think we talked a little bit about that. I think there are more questions coming here. Uh, yeah, I think there was one question about someone asking, is DevOps good for freshers and beginners? Yes. Automation, DevOps, please spend time. Like I said, I think there are a number of things that are connected. SRE, DevOps, automation, Jenkins, AI ops. All these five things will go together, and we from industry perspective are looking for lots and lots of engineers coming with these deep expertise. Either you take courses in your colleges around these five areas. Okay, let me repeat. So it's about DevOps, automation, Jenkins. We talked about AI ops, um, right? So I mean, these are five areas. Um, be very familiar when you come to industry, because we are looking for lots of people with those skills. Either you do Coursera, or pick up those pick up those in your universities. Okay. All right, let's do a time check. I think we've got another 2 minutes. Let me see if there are any um, final questions here. I think we talked about edge computing. We also talked about edge for edge. I will share. Um, no, I will share the slides. We talked about that. I think there were some questions around mechanical engineering. How that applies to. I think there are different industries. I can talk maybe about electrical engineering, because when we build a cloud, there are lots and lots of jobs available for hardware engineers, to build the supplies, optimize the racks, bring all the hypervisors, compute nodes, and stuff like that. So electrical engineering, electronics engineering, computer science engineering, information science engineering, data analytics, or data science engineering, AI, AI engineers. I think all these are related. I think you can somewhat bring in the mechanical engineering also, and perhaps one of the uses, things to do around CAD, computer aided design. You can think about those, how to leverage, what's available on cloud. You can think about that. So, uh, uh, using cloud for mechanical engineering. Uh, if I just stretch it a little bit, I think there are a lot of IoT use cases. So we have many customers who use cloud to run IoT use cases in manufacturing. In your end-to-end processes, and packaging, and many of those use cases. So there's the usage of IoT. When I say IoT, it's Internet of Things. So those type of things, bringing together, using cloud to take the data coming from IoT sensors, make some insights out of it, and then use that to control, many of the processes, and sending alerts and notifications and stuff like that. So that that's another good use of it. Okay, I think I answered good amount of this question. So thank you very much for these questions. I think there was one more question around AI and agriculture. That's a big topic on its own. How to use AI and cloud for agri industry. Phenomenal space. Weather forecasting. Things around seeding. Things around how do you harvest the crops. How do you look at how do you use drones, take the data from drones, looking at the field to see what's the density of where your water thing, how do you put how much amount of water in what space in the field. It's a phenomenal field, bringing agri industry with cloud and AI. I think we should probably talk it in one of the future future lectures. Okay, I think we are 7 o'clock, just 1 minute past. So thank you very much today for joining. And again, thank you very much, NPTEL team, for giving me this opportunity. It was a phenomenal experience for me connecting with you. So if you want to continue the discussions, like I said, I also have my Twitter handle, Girish D tweets. Follow me. We can continue the discussion. I'm open to having these open discussions, continuing some of these topics. Once again, thank you very much for the opportunity. And so I'm going to end. I'm going to end this at this point. Have a good night, everyone.